So in this video we're going to be going over the limit laws, and I got them all written down for you right in front. So the first one is just the limit as x goes to some number c of x is equal to c. And then another one is going to be the limit as x goes to c of some constant k is just equal to the constant k. Those are two important ones. Pretty much all of these are important and they're pretty straightforward. So the next one is going to be when you have some function multiplied by some constant. So the limit as x goes to c of some constant times a function, all it says is that you can bring the constant out front and take the limit of the function and just multiply it by that. And the next one just says the limit as x goes to c of the function of f of x plus the function of g of x. All that says is you could just take the limit of each function, so the limit as x goes to c of f of x plus the limit as x goes to c of g of x. So you could just pretty much just take the limit of f of x and g of x and then just add them together. The next one is just if two functions are being multiplied, you could pretty much do the same thing. The limit as x goes to c of f of x times g of x is just equal to the limit as x goes to c of f of x times the limit as x goes to c of g of x. Yes, it's a lot to say, I know. And this one up here with adding functions, it's the same thing if you're minusing it as well. You could take the limit as x goes to c of f of x minus g of x. It's just equal to the same thing. Just you could take the limit of each function and just evaluate it that way. And the last one is just the limit as x goes to c of just a rational function f of x divided by g of x. All you do is just take the limit as x goes to c of f of x divided by the limit as x goes to c of g of x, as long as g of x does not equal 0. So those are our basic limit laws that we know now. And I'm not going to review them because you should know them, and I know some problems can be pretty tedious and instructors want to know, so just remember if we have some number c of x, we just take the c as the answer. If we have the limit as x goes to c of some constant, it's just equal to the constant. If we have the limit as x goes to c, if we have the limit of some constant times a function, we could bring the constant out front and evaluate the limit times. We could evaluate the limit of the function. If we have the limit as x goes to c of two functions being added or subtracted, we could just take the limit of each function and add or subtract them. And the same thing goes for this one. The limit as we could take the limit of two functions being multiplied, and all you do is just take the limit of each one and multiply them. I mean, it's pretty straightforward. You know, you could think of it as just distributing out maybe, or just maybe factoring. You can see it algebra-wise, you know. So let's just do a few examples here. So the first example is going to be the limit as x goes to 9, x. Well, that's just going to be equal to 9, because remember, our limit law, the limit as x goes to c of some number x is just equal to the number c. So we can think of the 9 as c, and the limit is just the number c. Just by that limit law, pretty straightforward, right? So limit as x goes to 9 of x is just equal to 9. Same thing, and we could prove that just using the limit law. The limit as x goes to c of x is just equal to the number c. Pretty straightforward, right? Well, let's do this one now. This one might seem a little trickier, but we could just prove it using the limit laws. The limit as x goes to 9 of some constant 14. What do you think that's going to be? Well, remember, it's just going to be 14. Why is it going to be 14? Because remember, by our limit law, the limit as x goes to some constant c to some, not some constant c, just to some number c of some constant k is just equal to k. That's what we did. The limit as x goes to c of some constant k is just equal to the constant k. The limit as x goes to 9 of 14 is just equal to 14. Pretty simple, right? So let's just do a few more of those ones. So the limit as x goes to 100 of x. Well, just remember the limit law that the limit as x goes to c of x is just equal to the number c. Or we could think of 100 as our c, so it's just equal to 100. Pretty straightforward, right? So the limit as x goes to 100 of x is just equal to 100. And we could prove it using this equation, this limit law, I should say. The limit as x goes to c of some of x is equal to the number c. We can say the limit as x goes to 1 million of some number 1. Well, it's just equal to 1. Because remember, by our limit laws, yes, I know I'm saying limit laws a lot, but it's important to get it down. The limit as x goes to c of any constant k is just equal to k. So the limit as x goes to 1 million of 1 is just equal to 1. It's just pretty straightforward. It's just using your equations. So now let's get a little harder with these. Let's do the limit as x goes to -3 of 3x plus 4. Seems a little harder, right? But it's actually just breaking it up. So we got so we got a constant. We can use our multiple constant equation there. Then we could just break this up. So it's two things being added and something being multiplied. So let's just do it step by step. So we'll just write the limit as x goes to -3 of 3x plus the limit as x goes to -3 of 4. And for this one, we just used the limit as x goes to some number c, f of x plus g of x. This is just equal to the limit as x goes to some number c, f of x plus the limit as x goes to some number c of g of x. So that's what we did right there. But now we can use a different equation to break this up. Because remember, we could bring the 3 out at front and we could evaluate the limit of the function itself. And we'll just rewrite that. So for this one, we'll just bring this out here. You just use the limit as x goes to c, some constant k times f of x is equal to k times the limit as x goes to c of f of x. And so now, just using what we know, well, what's the limit as x goes to -3 of x? Well, we know that because we know our limit laws. So it's going to be 3 times -3 plus 4. Did you get that? So remember, the limit, it's right here. So, well, what is that going to equal? It's going to equal -9 plus 4, which just equals -5. If I'm not mistaken. You can go ahead and check that real quick, just to confirm that we did that right. And we did do that right, so touche, touche. So let's do another one that's even harder than that one. Let's do the limit as x goes to 1/2 4x plus 1 times 2x minus 1. So let's just evaluate this. So I'm just going to break everything up right here and just do it the easy way. So we're going to do 4 times the limit. So x goes to 1/2 of x plus the limit as x goes to 1/2 of 1, all of this multiplied by 2 times the limit as x goes to 1/2 of x minus the limit as x goes to 1/2 of 1. So did you get what I did there? So we just used our constant multiple. We bring the 4 out front and we multiply it, and we just evaluate the function by itself. And then we just take the limit of that by itself. So I pretty much just skipped a step. Like I could have rewrote the limit of all this times the limit of all this. Then I just skipped a step. So now it's going to be, let's just evaluate this now. So it's going to be 4, well, knowing our limit laws, we know it's 4 times 1/2 plus 1 times 2 times 1/2 minus 1. So then this is going to be 2 plus 1 times 1 minus 1. And this just all equals 0, if I'm not mistaken. It does equal 0, as it says in the solutions manual. If you don't understand what we did there, you should just go over your limit laws, but I'll go over it real quick with you. So what we did is we used the equation right here. We just used k times the limit as x goes to some number c of f of x. And right here, it's pretty straightforward. We just, you just gotta know your multiple laws, pretty much. You just gotta memorize them. So we had two functions being added together, so we split them up, evaluated them, and just evaluate them individually. But we still have that 4x, so we have to bring the 4 out in front because it's just a constant. And then you just do the same thing here. You have two functions being minus. You evaluate them. You just evaluate them using the limit. But you still have that 2 there, so you just bring it out front. And the reason you don't evaluate that 1, like you did that 2, like you don't bring the 1 out in front, is because it's just 1. It's just a constant. It's just some constant 1. And that's what that law says. Limit, we'll write down here. Limit as x goes to some number c, k times f of x is equal to k times the limit of f, the limit as x goes to c of f of x. That's the reason why you don't put that 1 out front like you did for the 2, is because it's 2x. It's just not 2. Because 2 is just a constant. 2x is not a constant. It's a function. So that's why you do it, because you have some constant. And if you don't know what a constant is, it's just some number. It doesn't have an x, doesn't have y, doesn't have smiley face. It's just a number. So let's see